somebody to maybe close the doors to keep the noise from outside? Outside? And how about another hand for Deb Main that's keeping this all going so smoothly? We're not even noticing the technology is working so great.
Yeah, well, it'll be at least an hour. There's no film. This is just
Okay, let's let this.
about climate change. Yeah.
And if you need a seat, we got like the second row is just about empty, so come on down.
So, I'm sorry. You're kind of like right now to see the presenter. Sorry.
Okay, so Geoff McQuilkin, you've been part of every climate seminar too. And I always really look forward to Geoff's report every year because he just has such a great big picture viewpoint of Mono Lake in the great scheme of things. And there's always some really great update, up to the minute graphics and research and lake levels and everything. So Geoff McQuilkin, the Executive Director of the Mono Lake Committee.
Thank you, David. I have been to all of these, and I did go out yesterday and take 2 pictures of the presentation, so I appreciate your up-to-the-minute acknowledgement. It's great to be doing these, and of course I've been inspired by these young people, so I'm just going to acknowledge them. I've been very involved in their travel plans, going to the CCL and texting, and whether there was a toaster in the Airbnb or not, and some other thing. There was not. Rainier took a little heat for that there in Washington, but very proud and inspired to see them here. So you guys are awesome. You know that. So I'm going to talk about Mono Lake in the era of climate change, and as Jan said, I have done this for all the years, and so I did try to come up with some things to talk about that were not repetitive of the same thing from previous years. So I want to give you a little sense of the outlook for Mono Lake in the next year, and then talk about what's put us into the position we're in with water diversions and lake level and so forth. But this year I wanted to really focus in on resilience and talk a bit about how we're trying to better understand the Mono Lake model and how we forecast where the lake's going in the future. And then also talk about some really exciting developments in stream flow and stream flow management that are brand new and putting wet water in places it hasn't been before this year out on Rush and Levining and Parker and Walker Creeks. So they're really exciting. So let's see. Janet said I have unlimited time, so I've got an additional 50 slides at the end here that I can do. No, you guys, no, we're talking about Mono Lake, we're talking about the Mono Basin, our closed basin watershed here, and thinking about the future and climate change with regard to the streams that come out of the Sierra, Mono Lake's level, the health of the streams. And there's been some good news recently, and we got to celebrate that. I'm still living with the good news of 2017's wet winter, which we can toggle back and forth from here. We went through that drought, and it was kind of rough giving this presentation during the drought years. And then we see Mono Lake coming up during after the big wet winter of 2017. What's going to happen? Oh yeah, so we've got it might even go too, because these are the greatest hits, so we really have to enjoy these. Lake level rise in 2017. Kayla and I just recently went out to a similar spot to put in this year's time-lapse camera because we are expecting a lake level rise of about, we're going to get the fade here. We'd like to not see those tufa shoals again. And Deb, I don't know if I can advance out of here. Oh, that's good. So this year, also a wet winter, about 144% of average runoff forecast for the Mono Basin. 2017 was up at 200+%, so definitely a wetter year. But our forecast for this year, Deb, I'm going to try and make it go forward to my next slide, but it doesn't want to, because it's so happy showing the video. We'll see. I think if you do one, I bet it'll let me do the rest. Maybe. Or the video was so great, did it? We'll see. Yeah, let's see it again. So our forecast for this year, which we'll see in a second, is about 1.5 feet of net rise in Mono Lake by April 1 of next year, 2020, reflecting the wet winter that we had. Let's see. There it is. 1.5 feet. I'm going to go back to full screen and you'll see it. And this, of course, is part of what we like to do with the Mono Lake Committee, is try to really understand the lake dynamics and understand where things are headed. As I've mentioned in previous years, this can prove to be a lot more reliable when you look 12 months out than when you try to look 10, 20, 30 years out. One of the things we've been grappling with over the past couple of years, and we'll get to that. And then, you can't talk about Mono Lake without this graph, which is so confusing, but contains every piece of information you could ever want to know. So you can all look at it and pick out your favorite factoid from it. I'll just illustrate here. Let's see if I can do it. This is the State Water Board Resources Control Board decision in time here back in 1994, and we've been watching the lake go up, and then unfortunately, the 5-year drought, and then recover in 2017, and now we're looking at this forecasted rise by next year, all in the larger context of the lake falling. So we know that we have Mono Lake. We know we've got snow in the Sierra. There are other sources of water, but that's the primary one that comes in. We think about climate change. Sometimes it's easy to think like, well, here we are. Okay, we're going to start from where Mono Lake is, and climate change is going to impact the lake. Well, that's true, of course, because it is where it is. But what happened in the past was a grand simulation of climate change, if you'd like to look at it that way. We had the diversions of the Los Angeles Aqueduct imposing drought conditions on Mono Lake. It wasn't necessarily a drought here in the Mono Basin or in the Sierra, but in terms of Mono Lake and what was arriving down the tributary streams. The LA Aqueduct, starting in 1941, diverted a tremendous amount of water and the entire flow of the streams for many decades southward. And you guys know this history, and you know the public trust doctrine and the fish and game codes and the legal fights, the state water board code. If you don't, come on over to the Mono Lake Committee and we'll tell you about it for 400 hours. Or 1 hour in a very concise and well-led field trip down at South Tufa. But the key being that it dropped the lake from when exports began substantially. And for this presentation, thanks to Janet inviting me the first year, I went back and made these graphs. This is Mono Basin runoff, so snowmelt runoff coming out of the Sierra into the lake in all these years since the aqueduct began operation. And you can see there's a natural variation. Here's 100% of average, and we've done some drier years and some wetter years. But if you're at Mono Lake, if you are Mono Lake, what did Mono Lake experience on average was something like this, because all that other water disappeared down into the aqueduct system. So this is average. It did vary a little bit every year. But if you go back and forth, you can see we took a lot of water out of here, we Californians. Post water board decision, of course, there's a schedule of diversions that are focused on letting the lake rise. How much does it need to rise? Well, you may be familiar with the lake levels. We're at 6382. We need to get to 6392, so 10 vertical feet higher. It's helpful sometimes to think about in terms of volume. It's about 500,000 acre-feet, 450,000 acre-feet of water to get there. And the reason that matters is that what we've seen over the years is you need wet years to really ratchet the lake level up. You've got to add extra water. Every year there's water coming into the lake and there's water leaving by evaporation. So to boost the lake upward, you need those wet years like we saw in 2017 or this year. To add extra volume, we're looking for 450,000 acre-feet or so to get to that management level, and we've got 60,000 scheduled to come down the creek quickly. It seems to be starting yesterday. And then we've got the State Water Board decision, which continues to be inspired in tying the export of water in the aqueduct system to the actual level of Mono Lake. So rather than setting specific numbers for export, independent of what's happening at Mono Lake and hoping it works out, that export amount is tied to the actual level. So when we go through a drought situation, if we see climate change impacts coming to bear, that balance of export and lake level adapts automatically through this linkage. Okay, so we've got lake level, and in years past, so we've got lake level, and then I was going to give a quick review. Last year I went into a little more depth on a recent UCLA study focused in on the Sierra, talking about projecting climate change. They did some downscaling of the models. They really did a nice job of trying to present some regional information. It's a little daunting, but it's good to know this is the context, the best recent information for general context that we're working in. So at Mono Lake, we kind of think about two different things. One is the precipitation, how much water we're going to have to work with for the lake, and then there's the temperature. The interesting thing the group found about precipitation, and you can see in this headline, wetter, drier, or both, is that the models don't really show a big change in the amount of precipitation coming to the Sierra. Now it's going to be warmer, so a whole lot more of that's going to rain and a lot less is going to be snow, and that's a very big change. In terms of actual water, they're kind of in the same zone, but what they find is more extreme dry years, more extreme wet years. And they're forecasting about 2 times as many dry years and 2.5 times as many wet years. Less in the middle, more at the extremes, and more common flip-flopping back and forth. In the old days we'd say, oh, it was a wet year, probably have another couple of wet years. They sort of come in 2s and 3s, that kind of thing. And it may be much more of the seesaw that we experienced 2015, one of the driest years on record in the Mono Basin. 2017, one of the wettest. There you go. Very, very quick. That might influence how we see stream flow delivery, how the lake rises. And then these are the folks who did this. We had a great chance to interview Alex Hall, the lead researcher in the Mono Lake newsletter last year, so you can search that out online if you like. But they did this Sierra-wide analysis on the temperature side here. So they're looking at historical climate and showing average spring temperatures. And then from that baseline, they're looking at what's the forecasted change in this century, so by the end of this century. And it's a little scary in terms of color. What they're basically looking at in terms of springtime temperatures here are average rises in the 7 to 10 degree Fahrenheit range. This is by 2100, and this is in the business as usual scenario. So again, we're going to thank all of our climate activists here in this room and our young folks, because it doesn't have to be this bad. This is the no one does anything scenario. Things keep going. They've also done that projection looking at the eastern Sierra here as well, and you can see that temperature increase just broadly distributed throughout our watershed by the end of the century. That affects snowpack. So this is a graph showing, or not a graph, but a color representation of changes in snowpack that we might experience in the springtime. Of course, if it's getting warmer, maybe less of that snow is arriving, more of it's arriving as rain in the first place, and the season is warming up more quickly, so you're getting an earlier melt cycle, and by the time you get to kind of a classic April 1st snow point, which historically has been our maximum snow depth, that's when you go out and you measure everything, they're projecting up to 60% decline, and that's what Ellery mentioned actually, in the Sierra snowpack by the end of the century. In the business as usual, no one does anything scenario. The hopeful part of it is, and Ellery mentioned this too, so here's our 64% drop in springtime Sierra snowpack under business as usual, only 30% if immediate actions are taken, the type of things that the students are talking about, the Paris Climate Accord, these kind of measures actually being fully implemented. So there's, it's not a lost cause, but action needed very quickly. The other thing I'll highlight here is this last piece talks about the change in timing of stream runoff, and when's the snow melting and when's it coming down the streams, and when are those peak flows arriving. 25 to 50 days earlier, so we like to have the Chautauqua and the climate panel and have to come and talk about peak flows coming in and snows melting. And imagine if that was happening a month or two earlier. It's a very different time. Trees, vegetation, not really adapted to that. The temperatures might not even be leafed out. So one of the biggest impacts we're looking at and thinking about is what might happen on the streams with this kind of change. So we know the temperatures already rising And even in this more optimistic scenario where we're taking action, we're looking at that type of runoff timing change. Okay, so Mono Lake. This is our classic lake level balance graphic. If you have your souvenir edition of the Mono Lake guidebook somewhere tucked away, you may recognize this. You know, this really came from the early days when we were trying to explain why is there a salt lake out there and why is it salty and what does that mean anyway that there's no river leaving it. Of course, so you have, here showing the inflow coming out of the Sierra snow melt streams, some additional sources, precipitation, and then essentially, evaporation being the method by which water leaves Mono Lake. This was a good educational piece. It still works, but it is a little more complicated than that. And what we've been trying to do at the committee in recent years is look more carefully at the model, look at the conceptual part of the model, look at the actual math part that you do. And we've used these for a long time, but we're anticipating changes, and we want to know what's going on, how are these holding up, and so forth. So I thought I'd just take you through a little bit of the more detailed model. And Maureen, who's here, and Robbie, who's maybe not here, and others are working on this and scratching their heads and thinking about all this data and all these things. So I want to recognize them along with Peter Horster, our hydrologist. So here's what we look at when we get from the graphic and we get down to it with the actual Mono Lake model. Where does Mono Lake get water from? Well, Sierra runoff coming out of gauge streams, Rush Creek, Levining Creek, Mill Creek, Walker, Parker, and so forth. For sure, that's the really big contribution. Precipitation east of the crest, so precipitation at just, the thunderstorm this afternoon, the rainstorm that rains on Mono Lake, the snowstorm that actually deposits snow right into Mono Lake, that's a contribution. And then a little bit smaller sources, ungauged Sierra runoff, so what would that be? Maybe the creek that runs through County Park out there. There are places that there's water coming down, but not being routinely measured like the DUP does on the big streams. And then there's some smaller inputs from outside the Sierra, so the Bodie Hills and so forth, usually ephemeral. So we're trying to keep track of all of those when you think about what's going into Mono Lake. And then when you think about, well, what's leaving Mono Lake itself, really, evaporation, of course. But you do think about that water on its way to Mono Lake, and there are some other possibilities that might happen to it, and try to account for all of those. Evapotranspiration, which we've got trees and vegetation and all kinds of places that the water might be used by plants along the way. There's a few special things like Grant Lake Reservoir, which is parking water there, and there's some evaporative loss from Grant Lake. Bare ground evaporation, kind of evaporation on the journey down the streams. We've got municipal and domestic use. We talk about LA. Well, we're really talking about Lee Vining, and June Lake, and Mono City. I mean, there's some consumption of water there. It's not that much in the scale of things, but you need to account for it. And then, of course, the big one. So surface water export. How big are the diversions Los Angeles is making out, causing that water to not reach the lake? Very important in the balance. And then, always accounted for, but a little less known, groundwater export. Are there groundwater pumping wells in the Mono Basin like there are in the Owens Valley? No, they don't. There's no pumping here. But the tunnel through the Mono Crater actually serves as kind of a horizontal tunnel. It picks up groundwater that flows in there, and even when diversions are shut off and no water is being removed from Grant Reservoir and sent to Los Angeles, there's a flow that comes out the other side. And so that's removing about 12 CFS or so of continuous flow leaving the Mono Basin. So you have to account for that as well. So then you get to a graphic like this, Maureen's favorite, I know, right? From Peter Horster's Mono Basin water balance back in 1985. That's a little more nuanced and really lays out how you would deal with all these different inputs, where they come from, and then you can start to put together the equation that's going to describe what's happening and give you a potential to say, okay, if there's more coming in from a wet year, what do we think the lake response might be? What if at 2, 3, 4 years if you're trying to project lake level outward? A few other factors to mention as well. Groundwater storage effect, I'll talk about that in a second. Kind of keep an eye on if the lake changes its bathymetry, if the volume of the lake changed, volcanic eruption, sediment accumulation, not that big a factor, but you got to keep an eye on it. Also, if the area of the lake is changing, which might happen from shoreline erosion as the lake rises, it usually is cutting back in there. The amount of lake area affects how much is lost to evaporation because that tells you how much is exposed. So we're going by long-established charts on a certain lake level, how much area is there, how much evaporative surface is there to calculate how much loss is when you work on a model like this, but you got to make sure that hasn't changed in a significant way. And then the last one goes back to the climate projection. Greater variability of wet and dry years can be an influence because it may be that things just don't look like we're used to seeing them because we're going back and forth. We're getting the wet year, we're getting the dry year, we're getting the big drought impact. And that's important for looking at the forecast. So you could just do it like this, I only put this in here really to make you laugh in there. So there's a formula that accounts for all these things, plus a few others, like the changing salinity of the lake at different elevations with different salinities, because that affects its evaporative loss and so forth. The key point I would make is the accuracy of the equation, or what it produces for us, what our interest is, lake levels in the future, depends on the accuracy of the input. And some things are very well measured. The Department of Water and Power is very good at measuring the flow of the major tributary streams, for example. Very reliable data history. But some things seem like maybe they've changed, or maybe we should at least look into it and see if they've changed since the 80s, the 90s, when a lot of the focused work was being done on the model. So what are high priority components for further study that we've mapped out? These aren't the only ones, others are certainly possible, but as we've looked at all these pieces, I just kind of ran you through. The 4 on the list are gauge Sierra runoff, east of the crest precipitation, evaporation, and groundwater storage. So what does that mean? Why would we want to think about it? Well, gauge Sierra runoff, that's how much water is coming down, Rush Creek, Levining Creek. I mean, if that was plummeting now or in the future in a climate change scenario, that's going to be a big difference in what happens at Mono Lake. 50-year running average has been pretty stable, but there's some things you could look into here. Is 50 years really the best interval to use, or something to look at that's a shorter, more recent time period? And also, of course, that doesn't tell us what's going to happen in the future. So being able to connect in some climate models with actual lake forecasting, so we're not just relying on past hydrology and information, but we're able to think about how things are changing, is important. So I don't have the answer for you today, but I'm flagging it because this is on any of these really, but this is something we've been looking at carefully as we try to get up to date with the most accurate, most recent possibilities for running the model. Another one is east of the crest precipitation, and we've identified this one for a while. It's not the biggest contributor to Mono Lake's level, but it does seem to have had a measurable change in the past 20 years, 15 years. But then again, it's not that well measured, so do we really know what's going on? So the reason I put this photo in here is that this is a relatively new precipitation station that's out on the northeast shore. And the Great Basin Air Pollution Control District is running this in association with some other components there, and gathering precipitation data. Right now, when you try to use the model and you want to say how much water is Mono Lake receiving from this non-Sierra precipitation, you look at what's measured at Cane Branch down by the Jim Lake Route, and you kind of project that outward using the best formula you can for everywhere, but it's only one station. And we do see some changes there, and the question is, do those changes, that are measured where right about here, are they equally reflected across? Could it be drier, even drier out here? Could it be just this area, etc.? So gathering some more data, doing some more analysis can help understand if what you assumed in the past for this factor in Mono Lake's level is still the right thing to be assuming, putting into the formula going forward. Another one, a big one, is evaporation. I didn't have a really good photo of evaporation, so I just went with the scenic Mona Lake photo, but I can guarantee you it's evaporating in this photo. So, probably not making rainbows through the event. At any rate, evaporation, Peter Forster and his water balance model, again back in the 80s, did some hands-on evaporation pans, some measurements. There was some correlation with nearby sites. You can develop ways of estimating evaporation, but the reality is no one's really been out there attempting to measure evaporation directly in a number of decades. It seems like it's a possible candidate for change and changing climate. There's some interesting debate about how much would a rising air temperature really affect evaporation versus the energy balance caused by solar. Maybe there's a solar input to the lake. Maybe it relates more to changing weather conditions and shading or clear days and so forth. Answer not exactly known, but in terms of research that could be done, things that could be looked into, evaporation, actual measurement of evaporation at Mona Lake could be a really helpful and important way of understanding where we're at now. And then the last one is really obscure, but always kind of interesting whenever it comes up. And it has to do with the fact that as the lake went down, so here this illustration shows it back at 6415, kind of a pre-diversion there, and then going down to near its low point. So as the lake fell, this 40 feet shown here, not only did the lake go down, but all the groundwater underneath nearby lands that was being held there by the pressure of the lake being full, lake goes down, that groundwater starts to flow down into the lake. And there's sort of a hypothesis that that may have slowed the lake's fall beneficially, because it's got this sort of unusual source, but it's a one-time resource. And it may also be slowing the rise, because the lake rises, and we all go out there and look at it afoot, but how much water needs to go into refilling this groundwater area adjacent to the lake in a particular wet year. So it may be slowing the rise as well as slowing the fall. We don't really, we know it's a factor and it was accounted for in the original model, but it could definitely be different or more substantial than we think. Things like this totally obscure, if you know where this is, you get a gold star for the day for the climate presentation. This is a DWP well that happens to be measuring groundwater, depth of groundwater, over by Levining Creek. One of the places that could be very helpful in studying this might be a need to do more like that. So when we talk about what kind of research, what kind of data gathering would be helpful in understanding what's changing out there on the ground, things like this can be very helpful. Okay, so resilience, yeah. The capacity of a system to recover from stress and disturbance while retaining its essential functions and structure. So there's a lot of talk about resilience in climate change thinking. There's talk about like on the Sierra, if we can restore mountain meadows, they can store water if they've been damaged or degraded over time. The challenge at Mona Lake is we've already suffered quite a bit of stress and disturbance. And so we're kind of racing to restore Mona Lake at the same time we're hoping that it will be in a good and strong and healthy position to take what climate change is throwing at the lake and the streams. And the good news from this year is that on the streams, we have come a long way. So this is Levining Creek, more or less what you could see from the back patio here are the visitor center, zoomed in a little bit, 1970s. You'll note the lush riparian vegetation, the flowing, meandering stream channels, the fish jumping out. No, this is in the era of full diversion of Levining Creek into the aqueduct. And you've been out there, you're familiar with, we've got a few pictures, but we've had an amazing recovery. And what the resilience strategy can be for our streams is to really try and get that restoration maximized so that the streams are in a stronger position, the riparian habitat, the forest, the plants are in a better position to deal with the changes we know are coming, whether it's runoff timing, temperature, and so forth. These Jeffrey pines, by the way, are my favorite because they made it through. They're still down there on the county road. Same story on Rush Creek. Late 1970s here. It was nice there was a sign, but you wouldn't have known it was a creek, right? Okay, so what's happening now? Well, there's news to report from this very year, 2019, that's really exciting. And I'm proud that the Mono Lake Committee, we've been working on this for a long time. You may have read about the stream restoration agreement that we reached way yonder back in 2013 with the Department of Water and Power and our friends at Caltrout and the Department of Fish and Wildlife that set forth that these new stream flows, better stream flows, restorative stream flows would happen. As happens from time to time, this got caught up in a lot of long processes and is still ongoing to get this to its final conclusion, getting that agreement turned into actual water license terms. We're getting actually quite close now. But in the interim, the Department of Water and Power this year is implementing with the State Water Board's approval essentially those flows that were called for in that agreement. And they've been studied for many years by stream experts and developed to replace the older flows and provide some really significant new benefits. So what are those? We're going to be a test afterward, so you can memorize all of these. No, this is the highlight. So Leave Onion Creek, let's take a look at Leave Onion Creek. The old requirements, which were a real step forward when the Water Board put these out, gave us several different year types, dry, normal, and wet. We had minimum flows in the summer and in the fall, or going through the winter. And then there were some restoration-focused requirements, generally speaking, allow the peak flow to pass down the stream so that high snowmelt flood in the springtime, because we know that it's really beneficial. Did that work out always? Not so much with the peak. The minimum flows were pretty good, but they were pretty simplified. Just 2 levels for a year. This graph shows you 2003 and what happened. So there's a game that happens when you say past the peak flow, and you're running an aqueduct system, and you're diverting water. You're now in the business of figuring out when the peak flow is. And Leave Onion Creek can be tricky. It could have multiple peak flows. The first one might look like it. Maybe the second one's bigger. Maybe you don't know what's happening. We found that a surprising number of peak flows arrive on holiday weekends. It's difficult to send people out and deal with the situation that you have a peak flow. Not quite sure why that is. So this is an illustration. The pink, you can ignore the dark line for this purpose, but the pink is the what's coming in at the Leave Onion Diversion Facility up in the canyon here. And the purple is what's leaving, and the difference is what's going into the aqueduct. And so you can see the pink here going up, and we're headed toward that peak flow. And what's happening to the actual stream flow? It's going down. It's attempting to catch up, never really makes it, and then they really open the aqueduct up, and boom, it goes way back down to these lower minimums, and you lose this whole high flow period here. The stream scientists who studied this extensively said, we always have known those high flows are important, that's why they're required. But apparently the rules aren't working, and it's just not delivering the results. So they came up with a more complicated, but really smart way of doing this. Essentially they figured out that there would be a minimum flow when flows are low, and then there'd be this whole set of requirements, about 220 different minimum flow based on what the actual flow of the creek is. So you're expecting to have more precise operations of the aqueduct, ability to divert in 1 CFS increments, or maybe 5 CFS increments. And then, LA's entitled to take some water. So you'd accomplish that diversion here in these middle flows, and then when the creek gets to 251 CFS, a bigger flow, you just shut it down, and you just let the flow go. And that's what's happening this year. It's for the first time. And it's a variance of the order, and DWP, to their credit, has put a lot of operator work into figuring this out. I mean, we can all look at the table and go, that sounds like a good idea. But if you have to go up there and run the facility and drop stop logs in and out and figure out the gate and things, it's a real change in operational procedure for them. And this is a graph of what's been happening this year up through yesterday. So you can see, again, the pink is the inflow coming into that diversion pond you may be familiar with. Blue is what's being let go down the creek, and the difference is what's going to the aqueduct, shown here in this green line. And you can see, my gosh, it worked. Look, the pink flow started to go up. We hit 250. The aqueduct shut itself down automatically, I might add, which was very exciting. So we now have inflow and outflow matched, and we're getting a peak flow in Levining Creek. DUP is getting the water that the license allows for. The creek is getting better flows. It only took a decade. It takes a long time, but we can get there. I mean, it's amazing. And so I did go down and take this picture yesterday. There you go. 305 CFS on Levining Creek yesterday, and it'll be going up from there. And so the diversions will stay shut down for the peak flow, and then they can pick back up when the stream flows drop back down into that middle range. How about Rush Creek? What's happened on Rush Creek? Well, we have stream ecosystem flows there as well. And here's the old rules and requirements. Again, kind of 2 minimum requirements given whatever year type you're in, more or less a summer and winter, and then a requirement about a high flow in the springtime. In this case, numerical instead of saying past the peak. Difficult to get this done. These are fine, but not very sophisticated in terms of matching or mimicking what a snowmelt stream does. You know, snowmelt streams, you guys see them, right? You're here. I mean, you get this up ramp, and then they kind of sit there for a little while, then they go through a peak, and then there's maybe a slow recession on the other side. That's not what's being described here. Guess what? The stream scientists decided they would describe that based on actual science and study in the field and determination of what really matters on Rush Creek for habitat restoration and what the results of different flows are. So this year we are now in this wet year set of stream flow requirements. We've got 10 different flow segments that go throughout the year from April 1st all the way to March 31st. And the goal of these segments is to describe much more accurately a set of flows that will mimic those natural conditions and give Rush Creek below Grant Dam. Not all the water would have gotten naturally, because again, there's a possibility and there's diversions that are allowed, but it's what's going to be released is going to be released in the most beneficial pattern possible. So they're really taking that same block of water Rush Creek would have gotten a couple of years ago, in similar conditions, and reprogramming it into a more ecologically beneficial way. One note about it though, big flows in the snowmelt flood and snowmelt peak, still waiting for that outlet to be built. Got to have that to make all of this work. And so that's on the table to get done, but the rest of this can be implemented right now, so why not? And we're going to see the reservoir spill possibly this weekend, so we're going to get something in terms of high flow, and we'll see how that goes. And this is just kind of an illustration from a few years back showing the difference between the old rules and the new rules in terms of how they operate. And that what the key thing is you push higher to these big flows. It does require an outlet to get up to that height, and you have a different recession coming down, and you're triggering actual beneficial ecological processes by getting into those higher flow bands. Deep pool scouring, bar formation, delta building, debris, the things that are shaping the stream, making